Hello, and thank you for attending Embarcadero Data U. In this session, we'll be getting physical. We'll learn to use some of the automation features of your modeling tool to quickly, easily, and reliably build crosscut features into your database schemas. This may get outside the comfort zone of purist modelers, but the pragmatists will gain a lot of leverage using these techniques. My name is Henry Olson. I'm in product management here at Embarcadero. I bring with me a background as a software architect, DBA, and data modeler. In my present position, I get the opportunity to work with some of our largest and most sophisticated customers. It's a great way to learn. Today we're going to talk about a case study, a specific real-world case trimmed down for teaching purposes. And we're going to talk about how we go from the logical to the physical, from the modeling level to the schema implementation level, and some of the steps along the way. Once we've covered the topics, then we're going to dig into a demonstration of the features that make this possible. So here's our case study. We've got an industrial distributor. They have a mission-critical system, their order entry and order management system, based on outdated technology. So the objective is pretty straightforward. It's to replace that costly, outdated mainframe system with something that's more modern, portable, flexible, and cost-effective. This is a strategic initiative for the company because for a wholesale distributor, this sort of system, the order management system, delivers competitive advantage. So this is the high-level challenge. Some of the key success criteria in this case are implementing on modern, portable, multi-tier platform, so we don't have that platform lock-in. To support distributed operations, this is an outfit with multiple warehouses and people in the field with mobile devices. So we've got to have a fair amount of flexibility for distributed processing. And then lastly, from the standpoint of good governance and audits, we want to make sure we're capable of capturing detailed history where and as necessary to support those governance initiatives and audits. So this is our case study. Let's take a look at how we might model some of this stuff out. So we start with a conceptual model, and this is a great vehicle for discussion with business sponsors, executives, and helps to understand the scope of the system. We see all the key nouns here, as well as some of the key definitions associated with those primary objects in the system. So here, in this wholesale distribution environment, we're talking about customers and products and the orders that the customers place. We're talking about products and warehouses and the inventory that's carried, and the orders and the shipments that are the bread and butter of a wholesale distributor. So this gives us a good vehicle for conversation, scoping, those sorts of things, but it doesn't get to a model that we can really implement. Peeling the next layer off, we discover some internal complexity around the sales order and the shipment. Orders can be for multiple items, and that has to be properly represented and normalized. We find that our customers do business in multiple locations, and that we may not be billing them at the same location where we're shipping the product. So we've discovered a little bit more detail about the problem domain, and in conversation with subject matter experts and review of some of the documents produced by the system, some of the existing data entry screens, we've been able to add the key attributes that we know we'll need as part of this system. So at a business level, we've now captured the data requirement to a degree, but we're still not there in terms of something we can implement. Notably, we're missing a key scheme here. We see the relationships, but not the keys. And further, we haven't yet talked about some of those critical requirements that are actually driving this project, and it's some of those things that'll take us down to the physical level and create an opportunity to deliver something really great from the modeling team. So the key success criteria are effectively cross-cut requirements. Because of this distributed operations requirement, we've got to handle distributed key generation. That is to say, there can't be a single source system that's generating all the keys. There has to be a mechanism for that to be done across multiple systems and multiple device types. We've also got to recognize that we've got lots of people working on the same data at the same time, and we've got to have a mechanism for concurrency control, and one that's going to work in this distributed environment. And then additionally, we talked about quality and auditability, the ability to change stamp the data, and in some cases to keep a detailed log of all of the history of all of the changes that have occurred to the data. And so in order to support those governance initiatives, we have to do something that essentially runs across the entire database here. So these are all, as I said, cross-cut requirements, which in some cases can be pretty challenging to implement. So let's take a look at how we might go about this, and we'll peel the next layer off. So, the architect will look at these and identify some design patterns that can be employed to address these things. Starting with the first, sort of the classic mechanism is to use GUIDs for surrogate primary keys. There's a lot of discussion about the merits or not of surrogate keys. But in this instance, it's absolutely an appropriate technology to solve this particular problem. Next, optimistic concurrency. So this is a technique by which every change to every record is stamped with a version ID. And this can then be used when updating. Effectively, the update SQL can verify that the record being updated is the same one that was initially read from the database before modification. If somebody has snuck in while we were editing the record and made a change, then the version ID will be different, and the predicate on the update, it says where version number equals 3. If that version number is 4, the update will miss, and we'll get some feedback that there was a collision. And so that's a good way to make this happen in a distributed environment. One of the classic technologies for persistence in the Java world, Hibernate, uses a species of this. And since we're looking at deploying on a modern portable architecture, we'll probably use Java and Hibernate. And so this is a good underlying data technology to support that. In terms of change stamping, it's really, when was the record created, when was it updated, and who did it. And so we're going to provide all of those fields on every table in the database. And then finally, for selected tables, and in particular our master data, which can cause a lot of ripple effects when changed, we're going to keep comprehensive change logs. So every time there's a change to any of those master data elements, we're going to capture what the record was before and what it was after, whether it was an insert, update, delete, when it happened, who did it. So these are the design patterns we're looking to implement. The next step is to figure out how do we do this from a technical standpoint. So for this example, we're going to look at Microsoft SQL Server as the target database. And the same sorts of things could be done with other database technologies. It was simply picked because it's a good demonstration vehicle. So in terms of this key strategy, the GUIDs, they're well supported by SQL Server. There's a unique identifier data type. It's a 16-byte binary. And there's a function, this new ID function, that can generate those for us within the database. As I mentioned, GUIDs can typically be generated on a variety of different platforms. So that means this identifier data type, we have the capability to create an identifier in the central database or on a mobile device with a high confidence that there won't be key collisions. So it's a great distributed technology, well supported by the underlying physical platform. The next piece is row versioning. So this is this technique for optimistic concurrency, and again, well supported by SQL Server. The row version exposes an automatically generated global binary change number. That means every time any row in the database is changed, that row version is bumped. And so what that means is that within the records, the change numbers are different with every change, increasing, but not necessarily congruent. There can be gaps in the sequence because other records in the database get updated. But for our purposes, row version is perfect for concurrency control. In terms of change stamping, we've got a little bit of DDL. We're going to define a couple of date times and a varchar, and some defaults to set the initial value. So that handles record creation. When we go into updates, we need a trigger. And so this trigger is essentially going to capture those updates and essentially stamp it with a timestamp for the updated as well as who did it. And it's important to note we're using UTC date. This is because we know we've got a distributed system for a national wholesale distributor. They're going to have different time zones operating. We want to make sure that we've got a single timeline for the application as a whole. So we're definitely going to use that coordinated universal time. So that's the change stamping. Let's take a look at the change log. So here's sort of the third pattern that we're looking at. We want to create an audit log table, and in this case we've designed a table that is universal in nature. That is, this particular table can accommodate changes from any of the source tables in the database, any of those master tables that we're going to track this way. The trigger here is a little bit more complex. It doesn't conveniently fit on a slide. The pseudocode is illustrated. The actual trigger runs to about 75 lines of code. And we'll take a little bit more detailed look at that coming up. But effectively, what the trigger does is determines, first of all, whether it's an insert, update, or delete that's happening. It's going to go ahead and get the user identity and the timestamp. And then it's going to pick off all of the keys that have been inserted or deleted. And for each of those, it's going to grab the before image, what was the record before, as XML, and then it's going to get the image after as XML, and it's going to take both of those things along with the previously gathered data and insert a log record. So we're using XML for this for these data images because there's good support for that within SQL Server. And by storing the changes in an XML field, we can design a single audit table that works across the entire database. So again, we've got a little bit of a DDL that's shared across the database and a trigger pattern that we're going to need to apply to multiple tables. So you may take a look at this and say, well, gosh, this is a useful technique, but I've got dozens, if not hundreds of tables. Keep in mind, what we're looking at is essentially a teaching database. A real-world schema for this kind of application would run to hundreds of tables. And so it begs the question, this is all well and good, but how can I get this done in an economic and efficient fashion? And that's really where the opportunity to dig in and get the most out of your data modeling tool comes up. So what we're going to use for this exercise, what we're going to demonstrate, is a use of the automation capabilities within ER Studio. And this is part of what makes it a real power tool. There's a lot of, let's say, built-in knowledge of the various database platforms. So basic schema generation is done very quickly and efficiently, and all of that's built in. But when we're looking to add these cross-cut features that are application-specific, that's really what the automation capabilities were designed for. So on the right-hand side, you can see a depiction of the various objects in the internal object model, ER Studio's object model, and we can recognize a number of these things. We've got diagrams and dictionaries, models, relationships, entities, attributes. All of the things that are exposed on the drawing canvas are essentially accessible in this internal object model and scriptable. So you see a little script fragment below, and this one is just essentially walking through the entities in a model and printing the name of the entity. So, very basic, but also very simple and pretty straightforward and easy to read. The language is Sax Basic, similar in nature to VB. So something that should be well understood by, in many organizations. So with that, we're going to jump into a demonstration using ER Studio Data Architect as the vehicle. Take a look at how some of these cross-cut concerns can be quickly and easily implemented using automation. All right then, let's jump into Data Architect and take a look at how we get from this high-level conceptual model that we saw before down to something that's implementable and operating. And so here we see that conceptual model that we saw before with major entities and the definitions. We also see the logical model that was constructed. That's the drill down from that, where we properly normalize the appropriate tables. We capture some attributes that we know are going to be necessary. In other words, we have the business content of the model pretty well set. Above and beyond that, we understand the relationships between the entities. But there are things missing. We've talked about, but not yet built, that primary key scheme. We've got the row versioning, the change stamps, the audit log. All of those things have to be put in place, and the question is, how do we do those things, and how do we do those things efficiently and effectively? So built into Data Architect, we've got the idea of domains. These are essentially reusable attribute definitions. And we've got one set up here, primary key. So we can take that and drag it over to customer here. And look what happens. We've created the primary key, and it's been propagated into the related entities. And we can actually jump in very quickly, change the name to conform to our naming standard. So we'll call this. Well, that's good, but it's maybe not quite as efficient as we'd hope. What if we had a way to make this a little bit more automatic? So that's where some of this automation scripting capability, the macro capability that we talked about, comes into play. So I can click on product here, for example, and pop up the context menu and take a look at this macro for adding the primary key. And you see that's done in one quick step. Well, that's good, but of course we've got a lot of tables. Again, this is a teaching model, not a real size model, but in the case that you had a bunch more, that would certainly take you a fair amount of time. So the good news is with the same macro code, we can actually add all the primary keys. And you see these have rippled through from primary to foreign. They conform to our naming specification. And if we jump in and take a look at one of these, the attribute here actually has the right kind of data type. It's a unique ID data type that's going to be automatically generated. And we've got a default here of new ID, so SQL Server is going to generate those for us. So we've gotten quite a lot of work done already. And the power of automation has made it pretty straightforward. Well, the question is, these things always change. How do you handle new entities? So, for example, let's suppose we've come to understand that we need to log, who we're shipping with, who the shipper is, whether it's FedEx or UPS or whatnot. So when I click to add a new entity, we've got some automation in there now. That automatically adds the primary key, and I'll call this table, this entity shipper. And when I do so, you'll note that the name of the primary key has been changed to correspond with our standard there. Now we can reach in and add a couple of standard domains, a name for the shipper, and perhaps a status. And go ahead and link that into the rest of our model. And we've quickly been able to make a change to the model to correspond to some newly discovered requirements. But in doing so, we've observed our primary key standard that we set in place, which makes it very, very easy to stay consistent with those standards and make sure that your tables are going to be constructed the same way every time. Well, we've seen some interesting magic here. So the question is, how did we make that happen? And the answer, as was mentioned earlier, is through the macro capability of ER Studio. So let's take a look at the specifics. If we go over to the macro tab here in the Explorer, you can see there are a wide variety, and we're really going to be concerned with the ones that were built custom for DataU for this demonstration around adding the audits, the PKs, and then some of the functions that implement those things. The other piece that we'll look at are the event handlers. So these are some standard script names that are loaded when the tool is loaded that allow you to attach custom functionality to certain events in the internal object lifecycle. And I'll explain all of that in just a moment. So first things first, let's take a look at the functionality that adds those primary keys. So And this is sort of a best practice here, is to separate out the custom code in subs and functions into a separate file. So you can either attach it to event handlers or run it manually. And so that's what we've done here. The core code is here, and then it's essentially accessed from those macros we saw in the context menus and from the event handlers. And I'll show you how that's done in just a minute. So let's take a look. The code in question is really about, first of all, handle create entity. So this is a handler that that we call when a new entity is created, and we essentially the flow of this thing, we're passed in the new entity that was created, as well as the diagram that it's on, and these are passed into this routine, which then has the charge to go ahead and apply and name the new primary key. So let's see what happens. We take those passed in objects, which are generic objects, and we cast them to the right type, in this case entity and diagram. And that just makes it easier when we're coding, allows us to use the IntelliSense so we can quickly determine what the what the methods and properties are on those objects. Then we go in and get the primary key domain. So you may remember that was defined over here in the data dictionary. You see this primary key domain. So we're going to go ahead and pull that out of the dictionary into this PK domain object. And from that, we're going to get the ID for that domain. So we've grabbed that information. Now we set the name of the standard names. This is where our sort of naming convention comes into play. What we're saying is that the attribute name is going to be the entity name plus ID with a space in between, and the primary key name will be the same thing with a PK. So we've essentially implemented a little bit of a standard naming convention right here, which will then be applied consistently because we're tying it to the directly into the events, the object event stream. So then we'll add that attribute. Remember we defined that attribute name. We're going to now add it to the set of attributes, link it to the domain, and then go in and set the primary key, the name of the primary key. So it's all pretty straightforward. It's that object model that I showed you before, and we're now going through and manipulating it by means of this fairly straightforward VB code. So that's the bit that handles the create. It adds the primary key when we create a new entity. And then there's that other case that we have to address, which is if we change the name of an entity, we have to go ahead and update the name of the primary key. And you saw that happen when the default name of the entity was propagated to the primary key when the entity was first created, and then it was updated when I renamed the entity to shipper, then to the name of the primary key was updated, as you see here. So this code is even more straightforward. We're again casting the entity object that we're receiving. We're setting the PK name based on the entity plus ID, again that naming standard that we defined. And then we're walking through all of the attributes, finding the primary key. Once we've done so, we're going to set the name. If for some reason that fails, we throw up a message box and let the user know. Otherwise, we rename the column name and jump out of the loop because we know that we're using single element primary keys, surrogate keys, so we know there'll only be one. We can jump out of the loop. So very straightforward code in this case to make that magic happen. So part of the magic is not just that we can do this code, but that it can actually run automatically. And that's where we have to hook into these event handlers. So let's look at where that happens. So here are some of the basic handlers, and here's the create entity handler. And all we're doing is this particular standard routine is going to be passed in the entity and the diagram, and we just turn around and hand it to that custom code that's over in this physical modeling functions file. And you see that there's some special syntax here. There's a pound uses that refers to that, so that essentially all of the functions that are defined in that custom file are available here. So by doing it this way, we make those functions available both automatically in the event handlers here, as well as from manually run macros as well. So all we're doing then is just taking those parameters, passing it into our custom routine. And by doing it this way, by separating the custom functionality from the standard event handling framework, we keep this file very clean and make it simple if we want to change the behavior to just call a different function. So that's a little bit of a good practice. It's also very helpful when you're designing and developing these routines, because if you have the ability to run them manually, that's a lot more straightforward than restarting the tool every time you want to reinitialize the event handler functions. So that's the mechanism for handling the create. The update is similar. We'll take a look at it here. Here we have some generic routines that are called with update types. And so in this case, there's an update entity handler, but there are a lot of different types of updates that can occur, and the name, the table name, the definition, etc. We just want to trap that entity name change and go ahead and pass it to our handler, which will then cause the primary key name to be changed. So that's how the magic happens. We've created some custom functions in this file, FizzFun, and we've linked it to the standard event handlers, which are initialized when the product starts up. And so in doing so, we made it so that any time we add a new entity onto the modeling canvas, it's automatically going to get a primary key of the right type, and the name is going to be kept in sync with the entity name. Having taken care of the primary key challenge, that piece of the requirements, now we need to turn to the row versioning and audit tracking requirements that have not yet been addressed. And this is where we really begin to get physical. So in order to do that, let's remind ourselves of what the target is in terms of those couple of key triggers that need to be built for each of the tables. So here's an example of one of them. And what we notice is that this one, which is a trigger for the warehouse table, the term warehouse appears throughout. So it's part of the trigger name. It's the target table, of course, and it appears throughout the rest of this trigger along with the name of the key. So this particular trigger can serve as a template, but the right values have to be substituted in. It makes it a great subject for automation. So this is that fairly straightforward row stamping trigger. Let's look at the logging trigger, which, as I mentioned before, is a little more complex. Again, the same sort of things apply. Here we're doing one for shipper, the shipper table, and we see shipper show up throughout, as well as shipper ID, in other words, the key in the table, alongside some specifics in terms of data elements that are a part of the shipper table. So all of those things essentially have to be subbed in to generate the right code. So again, a great target for automation. So let's jump over to the tool, and I think it's time to see a little bit more magic. So what we'll do here is use our context menu to activate the wizard here to generate the physical model. So this is a SQL Server physical, and it's targeting SQL Server 2012. Obviously, you can choose exactly what database engine you're going to target. And we can step through this fairly quickly, for the most part taking the defaults. We'll choose a naming standard. I happen to like camel case, so we'll use that. And then I think we've got everything set to generate the model. So the tool will generate the model, and then following that, one of our macros is going to be triggered, and we see what's happening. We're adding all of those row change elements are being added as columns to each of the tables. So this works in a very similar fashion to what we saw before. There's an event handler for model creation, and when that's triggered, it calls one of our custom routines. So we can take a quick look at that. Fairly similar in many ways to stuff that we've seen already. So here's the handle create model. This is sort of at the heart of the thing. And let's scroll down, take a quick look at this. So effectively what it's doing, we're casting the model, we're verifying that it's a physical model. If it's logical, we exit the sub. So we're going to print out the table name in case we're running this interactively. We can kind of track progress. And then it's pretty straightforward. We're going to add a created attribute, give it a data type and a default. Same for updated. Those work the same ways. We're adding the row version, and it's the special SQL Server row version data type. And then the change by, and we're setting the default here to system user. So all pretty straightforward mechanicals. We want to deny update on the created at stamp to public. We want to make sure that that's once that's set, it doesn't get changed. And then we see a couple of other things happening here. We're going to take that permission snippet here, and we're going to add on the audit trigger script. It's based on the table name. So we'll take a quick look at that. But essentially that takes that trigger that we saw before and makes a template of it, and we fill in the table name. So we'll take a quick look at that in a moment, but it's very straightforward, very mechanical coding there. Then the other thing that we do is we're gonna add change data logging to all of the independent entities. So we want to verify that they've got no foreign keys. We pass in the entity name and say if you haven't got any foreign keys, then let's go ahead and add that log trigger script based on this entity. So another templating exercise. So we concatenate this permission script, the audit stamping script, and the change data capture script all get added to the post SQL. So this is essentially some SQL that gets emitted after the DDL when the schema generator component runs. So we can take a look at these two things, the audit trigger script and the log trigger script, and you'll see it's fairly mechanical, straightforward stuff. So here's the audit trigger script, and essentially it's that same trigger we saw before where we're substituting in the table name as appropriate, and we're concatenating this script and then returning the value. So very straightforward stuff. The log trigger script is similar, just bigger, a little tedious to put together, but certainly not very complex. The other thing we saw was this thing of has no foreign keys. So here, essentially, we're going to loop through the attributes of the entity, and if there are any foreign keys in there, that sets this flag, and we negate that and return the value. So that allows us to determine which of the independent entities. So pretty straightforward in terms of the code, pretty easy to read, mechanical for much of it, and I think very good use of automation here. So now let's take this physical model that we've generated and take the next step, which is to build a schema from it. And again, we want the tool to do the work, and certainly ER Studio does a great job with that. So let's go ahead and generate a database here, and we're going to do it as a script file. And let's take a look at the generated SQL here. So we'll take that, capture all of that, and then jump over to Rapid SQL and find a place to plug that in. All right, so now we've got 1,000 lines of SQL code that I didn't have to write, We let the tool do the work, both standard features of ER Studio, as well as some of these custom automation macros. And it's generated quite a lot of useful logic for us. We've got a database, this DataU database set up. Let's go ahead and run this now. Make sure it runs correctly. It looks like it's getting the job done. Don't see any errors here. So now we've created this database. And the next thing to do is to verify that it does what we think it does. So I've constructed a little script here that connects to the DataU database and adds a couple of shippers, does some updates, does the same with warehouses, and then essentially takes a look at what ends up in the warehouse table, what ends up in the shipper table, and what we see in the audit log. So this is our way to verify that the mechanics that we intend to happen, the additional logic that we've injected into the database is operating properly. So we'll go ahead and fire this off, and we can see the results here. Here in the warehouse table, we can see those goods are being generated. We've got the data that we expect here, and we also have the created and updated timestamps. And you notice this record was updated, so there's a difference between those. We see those row versions getting incremented and the changed by showing up there with my identity. Similarly with the shipper table, we see the same thing in terms of the goods, the created, updated, and the row version. So all of that seems to be working correctly. And then down below, we have our audit log table, and this is an interesting table. It's a single table that can essentially capture the changes for any table within the database based on those triggers that we've generated. And we can see here we're capturing essentially a composite key. This is the only composite key in our design that's a combination of the table name, the primary key of the table, and the version that was associated with the change. So all of those things create a composite key, a change key, if you will. There's a change type, and we see inserts, updates, and deletes all represented here, along with a change timestamp, who did it, and then both the before and after image. So we can see what the data looked like before the change was made and what it was after. So for an insert, of course, there's no before image, just an after image. For an update, you get both. We, in this case, went from UPS to the fully spelt out name of United Parcel Service. And we've got a couple more inserts. And then here's a delete. So we decided we're not going to send anything via snail mail. And we have before image, but no after image for the delete. Here we have another update. We spelt out the name correctly. And then did a couple more inserts into the shipper table and one update there. So this demonstrates that we've achieved the key effects that we intended to. We've got the right kind of primary key behavior, the record stamping, the record versioning, and the audit trail all operating correctly. There's a fair amount of complexity around all of this, but importantly, there wasn't an awful lot of work done. The tool did the work with the help of a little bit of fairly straightforward automation code. So let's recap. We took a look at a particular case study, an industrial distributor with a system replacement initiative that really required them to embrace some new technology and stretch themselves a little bit in terms of what they're doing at the data level. We looked at the sort of the pure modeling for this, from the conceptual to the logical, and then dug in on some of these more challenging implementation requirements that required us to get at the physical level. We determined the appropriate architectural design patterns and researched the appropriate technology to use with respect to SQL Server, and came up with some templates, effectively, that could be used across multiple objects within the database. And then we looked at how you can use the automation capabilities of ER Studio to consistently and quickly deliver those cross-cut features throughout the data model. So we added a lot of capabilities to the production schema without a lot of coding effort or manual intervention. So this hopefully is a set of ideas and techniques, maybe a little bit different from your immediate challenges, but my hope would be that this might spark some ideas for things that you can use in your own practice.
In the ER Studio, what is the logical equivalence of unique indexes versus non-unique indexes? Ron was mentioning indexes in ER Studio can be designated as unique or not unique.
I think there are probably a couple of different things to think about here. Typically, you're going to use a unique index for a primary key or an alternate primary key, whereas a non-unique index is classically used as the index around a foreign key. And so when you see one of those one-to-many arrows, if you will, in the ER Studio diagram, you're going from a primary key, which is going to have a unique index on it in the source table, to a foreign key in the child table, and that'll be non-unique because there'll be multiple values of that same primary key in the child table. And ER Studio takes care of all of that for you and generates the right kind of indices based on the relationships that you've drawn.
And then Alf asked a question, and Ron, I think, chimed in. It was about, what if the database doesn't support blank in variables, table names, and field names? And Ron typed, you can translate logical to physical names, and the blank spaces can be eliminated or replaced with a underscore or something. Are there macros that will do that automatically, or?
Yeah, absolutely. So that's a great question. You can actually define relatively sophisticated naming standards templates, which will take your logical names spelt out in more or less normal English, and convert them to something that's acceptable syntactically to the database. And so, for example, in this particular case, I was using a naming standard called upper camel case. And so what it does is it converts all the words to initial caps and squeezes out all the spaces, and that makes the physical names then acceptable to the database. Some of the databases now, SQL Server in particular, allow you to add some bracket syntax around identifiers, so they can have spaces in them. But I find that a little clumsy to work with, so my preference is to squeeze out the spaces for database column names and use that camel case so you can see the beginning and ending of the words.
Okay, Rob asked, there are two optional relationships from customer location to sales order, and only one foreign key for that table. And Ron was talking about the diagram you were showing was the logical diagram. That said, the foreign keys would propagate into the physical model. Physical model, not question mark. I'm sort of looking at Henry while I'm reading. The column names on the target table could be different if both are required, i.e. role name, or they could be merged to the same column if desired. This is dependent on the business rules that the relationships are meant to represent.
Yeah, so that's a great question. Of course, Ron's got the right answer there, and that was well spotted. I think that probably flew past pretty quickly. That's really an artifact of having defined the relationships before adding the primary key. And so what happened when we did that little demonstration where we applied all of the primary keys, the primary key in that customer location table then propagated twice to the child table with the same name. And so it resolved to a single name. In fact, to complete that model, you need to assign some role names. One of those would be the bill to customer location. The other would be the ship to customer location. And so that was just effectively an artifact of the demo. The finished model would have role names for those two things, and there'd be separate foreign keys within the order table for bill to and ship to.
And Joel asked if you're going to share those sample macros. We're going to have a place where the slides and the replay links, and if there's any other demos and or source files from the presenters, Henry's putting his thumb up and he's nodding head in, up and down. So
Yeah, absolutely. So the folks on the webinar team here are going to get a site set up with all of the replays, with some links to the corresponding products and with the appropriate downloads if there are some collateral material. So in my case, there are a couple of specimen models and some macros and so on that others may find useful as a starting place to experiment with some of these techniques.
Maybe this question is for Ron and/or Henry. Alf in particular is using the developer edition of ER Studio that comes with Delphi and Red Studio and CBuilder Architect, and he wants to upgrade. Does he have to uninstall, or does he get like ER Studio, choose your favorite edition? Does it install over it, or does he upgrade? Do you know, Ron or Henry?
It depends on version as well. Whoops, we're getting out of COVID. Yeah, it depends on version, because some versions will coexist and other ones will detect and overlay.
I think what we're shipping right now is either 9.5 or 9.7 of the developer edition.
Yeah, and for instance, from 9.6 to 9.7, you can actually have them coexist. So you can install the later one and then you can delete the other one as a separate step.
And there's a question here from May. We have an application that utilizes GUIDs, or GUIDs. These always take on role names when they become foreign keys made up of entity name GUID. Can a macro be developed to search through such columns and automatically find the parent entity and create the relationships up to the parent in the reversed engineered data model?
Yeah, absolutely. So I think that'd be a great application for macros, and I think there are probably several of the macros that are included that might give you a starting point on that sort of thing. The key is just to understand how to navigate, iterate through those collections of objects. So through the table objects, through the attributes on the tables, to find the elements that you're interested in, and then navigate back to the parent. But that should all be very straightforward, I would think, through the macro interface and the internal object model.
Oh, can you apply a macro only to a subset of the model?
Sure, absolutely. Again, this will be down to programming logic of one kind or another. If your question, for example, was about that macro that I demonstrated that automatically created a primary key, and maybe you want to do that in certain parts of the model and not in others, that would involve some additional conditional logic. So let's say if I'm in this particular submodel, I don't want to apply that logic, or I do want to apply it. But I would think that would be a fairly straightforward change to what's been demonstrated here.
And I know, Henry, we were talking when you first came in about how do agile teams and sort of infrastructure, traditionally waterfall data architecture teams, how do they work together? Do you have advice or guidance about how teams might work together if they're working at different methods, paces? Even though now we're in a flat earth through the internet where we're all sort of there, but do you have any advice for that kind of mixed worlds, or wanting to be part of the same world?
Yeah, absolutely. And I think this is one of those sort of perennial questions that's been around for a long time. And as David and I were chatting earlier, it's certainly the case that that data modeling and Agile are the product of very different eras. The fundamental work in relational models and ER diagramming was done in the 60s and 70s. Very different time in terms of cost performance. Failure was just in systems was unacceptable, so they did a lot of design up front to reduce the risk of failure as you increase the investment on these very expensive systems. At the point today where the key development tool is the laptop, and it's got thousands of times the horsepower as those 1960s mainframes, the economics are so fundamentally different. We develop in a different way. instead of writing a lot of documents, we instead communicate through software. And so it's a very different paradigm, and there are cultural differences, there are methodology differences, and there are technology differences that make this an ongoing problem. I've certainly talked to many customers that have faced this challenge. Some of the things I think that have been effective really start with a rethink by the modeling team in terms of their role. Rather than being the cops or the enforcers, they think about adding value in terms that agile teams can understand and appreciate, which is really around pace and patterns. And so some of the folks that I've talked to that have had some success in this area have done things like bookending projects, helping up front with the definition of the conceptual models, providing patterns, well-accepted models for customer and product and some of those commonly reused things, so that the Agile team starts on a good foundation on their particular project or iteration, and then hitting the back end and helping with critical review of the data model that's been developed and understanding and recommending what, if any, refactoring may be required. I think the other thing that's required often is some training. Develop within the Agile teams, develop a greater appreciation for modeling and what it means and the value that it brings, and actually train the lead, let's say, service developer on the basics of data modeling so they can begin to use the tools and technologies and really contribute to a better data quality outcome that way. I think there's an ongoing opportunity, though, if we're going to communicate through software, to provide some of the same continuous integration techniques that are now widely used in software development, to provide those in the database realm. And certainly that's an area that we're very interested in here, and it's an area of ongoing research and development.